Spectrum launch coverage. All right, let's see what we got here, dude. All right. Okay.
Is named Onward and Upward. It is the return to flight for Spectrum. I'm John Galloway with NSF. NSF is providing launch media services for ISAR Aerospace this evening. And with me is Nicholas Pedrakis. Nicholas, how are you doing?
I'm very excited to be here and also very proud to be representing.
I know that nerd.
It's a very historic day. Yeah, it's really great to be standing on the pad for the second flight.
Outstanding. Well, not quite on the pad. We're a little bit away from the pad. The rocket's on the pad.
We're referring to the rocket, yeah.
A distance away. Nico, you're the chief engineer for Spectrum.
I am, yeah. I'm leading the technical development of our launch system, meaning the launch vehicle and the ground systems. That means defining the technical direction, roadmap, and architecture for all of our systems, spanning from GNC, avionics, propulsion, fluid system, ground system, and so on and so forth. Yeah.
Absolutely. So Nico here is the correct person to have on the stream if we want to talk about technical systems this evening, which is what we plan to do. We'll talk about where ISAR came from. We'll talk about the machine that they're going to be building.
He was doing Firefly like a week ago.
In mass.
Guys,
we'll talk about the rocket itself,
how
it's
force
built,
to be
the fuel
reckoned
that it
with.
uses, and all of those sorts of things. So we have quite a bit of content for you as the clock continues to tick down at T-minus 56 minutes and just about a half there. So this evening's launch is scheduled for 21:06 local time, putting us just under an hour away. And we have about a 15-minute window. Now, it's a night launch this evening, but we do expect Spectrum to be a very bright rocket with that propane engine.
Indeed, yeah, with all 9 engines lighting up on the first stage, it's going to be a bright object. This is driven essentially, so the time, both being a night launch and the duration of the window,
the 15-minute window.
Exactly, driven by the target orbit. So it's a sun-synchronous orbit, SSO, as we refer to it. Essentially has a property that satellites, in this case our customers, pass over the same location at the same local time with every pass.
It's kind of the shadows are the same every time. It's great for imaging.
Yeah. Exactly. So imaging, Earth observation, weather, it has this advantage that you have the same lighting conditions every single time.
Yep. Yeah. And from the map here, you can see we're zooming into Northern Europe. We'll talk a little bit more about that later. To Norway on the island of Andøya. This is a spaceport location up here. And the land that the launch pad is on is actually new terrain that was put here. We're inside the Arctic Circle right now. We're 300 kilometers inside the Arctic Circle, about 190 miles. And that piece of land was not there before we wanted to put a launch pad there, was it?
Exactly. So if you were to show the same image from 3-4 years ago, you would just see a coastline at this point. So essentially we had to build all through the civil works.
Yeah, Das is up there. He's up there with Brady and D.
Of Andøya Space.
They've been up there for a while.
That's where the launch pad now lies and where our vehicle is standing.
And those are the shots we keep seeing over on the other side of the screen here, folks. We've got cameras all over the pad. We've got tracking cameras. We've got some experimental onboard video that we'll also try to share with you. But all the coverage that we can share, we are glad that you are joining us live this evening. Now, we do want to talk about the previous flight because this is Flight 2 of Spectrum. Let's talk about Flight 1, about a year ago.
Yes, exactly. It was on the 30th of March, so roughly a year ago. And we had successful operations throughout the auto sequence, throughout the ground phases. We have successful release of the vehicle and liftoff.
Right.
And we were able to verify propulsion systems, avionics structures for the first roughly 30 seconds of flight until we had a loss of attitude control and the termination of the vehicle.
Absolutely. They say a picture's worth 1,000 words, but we've got some videos. That's probably like 1,000,000 words. Yeah. Let's roll a recap of what happened during Flight 1.
Oh, I hope this doesn't get flagged. I don't think NSF would flag me, but yeah, just in case. So this was their first attempt about a year ago. It didn't end well. Good ignition, good separation. Everything went good there. It's what happens right about now. Yeah, that part was not great.
If there's an award for the most beautiful launch pad, I think Andøya is right up there in the running.
Definitely, we have a good chance of winning that
award.
Yeah,
that's right. I am just on Twitch.
But Flight 1 did end in an anomaly, but it also ended in lots of data that you and your team have used to improve Spectrum for Flight 2.
100%. As we said, also for Flight 1, it was a test flight, meaning that we have all this valuable data that we take and transfer into learnings for the next versions of the vehicle, specifically also Flight 2. So we were able to verify a lot of systems during this first 30 seconds of ascent.
Yep.
So we learned
That's
a lot
works
of,
for NSF,
from
spaceman.
every second of engine data, from every second of structural data, every second of avionics data, you get all these learnings that you then transfer into engineering decisions that you then apply into your second vehicle or verify your requirements with that. Obviously, there were also some anomalies, some of them minor, some of them major, but it is exactly the reason why we perform this test
cool
flight.
launch
Our
pad, man.
main purpose is to obviously find a balance between simulating, testing on the ground, and then finally getting the courage of saying, yes, now we can fly.
Yep.
And this is where we get
Yep.
the most valuable data. So also specifically to the anomaly that we had that led to the termination, attitude control, we saw that there was a mismatch between what we modeled and the actual reality, which fed into our control algorithm and then finally led to this discrepancy and the actual non-conformity. This is something that we wouldn't have learned if we didn't get to the pad on this day, if we didn't fly the vehicle on the first flight.
Absolutely, and that is the process. I think a lot of people who are new to rocket
Interesting.
chasing, I can call it that,
Rocket chasing,
don't understand. They think that every flight is supposed to be completely perfect, but when you're designing a new vehicle from the ground up, this is how it goes. You can't just simulate forever. You need to get real-world truth. You need to get actual flight data, and that's how you do that. You get on the pad. And the good news is that ISAR wants to share that with us this evening. Look at the drone shot.
Oh, it's really impressive.
We will have all sorts of fantastic views, so please stick around. Also, send this to your friends and family. Let them know that a European company here is got a rocket on the pad ready to launch.
It
this
really is a
evening.
beautiful
now,
launch site.
Nico, I just said a European company. There are lots of companies that seem to be creating rockets these days. There are lots of rockets that we see flying. Why do we need another launch provider?
Well, it is true that the global launch activity is indeed accelerating rapidly. However, if we look at the numbers, Europe's launch cadence still remains comparatively low. If we just look at 2025, Europe had in total 8 launches, one of them being ours,
Right.
compared to roughly 200 in the US or roughly 200 in the US or 100 in China. And there is a huge need there for
China.
European launch vehicles in order to ensure the independent and reliable access to space. So space has become an integral part of our lives and of our economies. And we need to have independent access to space to not rely on externals. This has certain
Yeah,
risks
Thomas,
if
right?
we are
Adrian going.
lacking this capability, especially when we're talking about geopolitical
That's funny,
changes
man.
or changes in the global space market and space sector. We need to have this control of the entire chain, meaning having this
You wanna
very
turn off
important
subtitle?
infrastructure
Alright,
of
no
being able
problem.
to provide payload into space. And Europe lacks that. That's why we're here.
Absolutely. Space is such a critical platform. A lot of people don't understand
Cough
how
drop,
entwined in our daily lives that it is, and it's only going to get more entwined. So it makes sense that Europe should develop its own launch capabilities, its own systems to be able to put things into orbit. Now, the clock is continuing to tick, and we've just gone under T-minus 50 minutes as we continue to look at all the different parts of the pads. You'll see the venting, you'll see the rocket coming to life. We want to share all these views with you, but everything's looking good so far, isn't it?
It is. So far, everything looks great.
All right. So, Europe needs launch capabilities, but are there actually European customers who want to hire a company to need payloads launched?
Definitely.
Oh.
European global customers,
Business
we have a
end.
huge demand at this point.
Very nice.
And again, it boils down to the same fact that spaceflight is a core element of life and economy. Sometimes, I think, especially for people who are not directly involved in space, there is a misconception that it's only for research or for space exploration or driven by government. However, we've shown that in the last 20 years, there is a private market, both in launch service and satellite providers.
What are the little
You know,
nozzles
aspects of
around the
life,
center
as you said,
bell?
like navigation.
That's the gas generator exhaust. These engines are an open cycle, so they have a gas generator, and the exhaust comes out those little holes around the center engine. Note next time they show that, Aldesert, that it's not symmetrical, because there's going to be 8 inner dumps, but on one side there's going to be a 9th for the center engine, right? It's not like a perfectly symmetrical amount of holes. There is some asymmetry to it because, yeah, you got to take into account the exhaust dump for the center motor. Yep. Spectrum's using propane, dude. This is a propane-based launch vehicle, so
Discovery,
liquid
go at
oxygen
drop up.
and liquid propane, man. How many times is that going to get referenced in the next 48 minutes? It's gonna happen, isn't it? Well, I'll tell you what, boy, that's a dang good rocket, boy. I tell you what, there. It's gonna happen. What's up, Xerax? It's time my country catches a W. We'll see, man. We'll see. So actually, Nico, the engineers said that their control loop algorithm was not. It's actually crazy that they were forthcoming with that info. I actually think that's really neat. Their control loop algorithm was not based off of real world flight conditions. Guys, I'm not gonna lie to you, that's hard to do when you've never flown. It's hard to get it right when you've never flown something, right? So it seems like they had gimbal lock right after ignition, and that's what caused the rocket to fail. Yeah, not having your control loops understand that the rocket is flying and understanding the real world conditions, yeah, that's something that's extremely hard to model. It's hard to get that right until you send it to the pad. Like, not trying to make excuses. That's tough. You could do more hardware in the loop testing on a test stand or something if you really wanted to, or if you're planning on building a lot, just send another one.
Most of the learnings happen through actual testing.
Right, not just simulation.
You Europeans need this W. I'm rooting for you guys. I really am. I want this thing to go. This would be sick. You know? I love my American rockets. Don't get me wrong. Like, but, you know, you guys are bros across the pond. I want to see you guys do well as well. That would be great. Like I said this actually when we were playing Kerbal a little bit earlier. Dude, if we're going to do what NASA wants to do with leaning heavily into commercial for our moon base, we're going to need all the rockets we can get. So, please, more rockets better. Like to quote Jack, like, yo, this sucker needs to work. We're going to need more rockets like this, man.
That building this machine that builds the machine.
Vibration modes can be hard to detect before it's actually flying. Bingo, Olamar's. Yeah.
Site, and 8 years later,
that's just one of those things that's just really hard to get right until you actually get some flight data behind you. The acoustic environment, the vibration environment, those are hard to predict. It's hard to make a good model for it until you've actually flown the damn thing. So just something to take into account. That's a good point.
That really is an interesting sort of backstory. It's not, oh, here we're going to make a bunch of money doing launches. It's we need to provide this access for Europe, and that's how you got started.
Exactly. Yeah, seeing an actual need in this lack of
exactly. Now, if you can only simulate so much, at some point you're going to need some real world data. Exactly, dude. Yeah. You know, some people think like, well, you can't you just do CFD? Can't you just put it in ANSYS and just send it? Well, no. In ANSYS, you got to configure it. How do you know what the real world flight conditions are? What are your atmospheric models? Does your rocket understand what wind is? I know that sounds dumb, right? But it really is that. Like, is your simulation criteria even correct? That's important. That is why this stuff is so damn difficult, you know? There's only so much a test stand's going to tell you.
Working at ISAR is that you cover the whole process from design to testing to launching.
Where's this rocket launching from? It's launching from Andøya in Norway. Way northern Norway. They're well into the Arctic Circle up there, which is pretty cool.
We are dealing with every day. I'm really looking forward for the future of ISAR Aerospace. We got a world-class manufacturing team, smartest engineers, beautiful
That's right,
products,
Sam. You got it, buddy.
Nice launch sites.
You got to start somewhere.
What else do you want more?
The excitement here, it's crazy because you can see the evolution of a full rocket from zero till the end.
It's hard to scratch build this stuff, man. The difficulty is like unfathomable unless you're in the industry.
What comes to mind is teamwork and focus, especially if we are like in crunch time when it goes towards launch or to a stage test. You really feel the energy in the room and that everybody is trying to help out where he can.
That guy plays 40K, I'm convinced.
What I like most working at ISAR is that we're a relatively young startup still, so there's still a lot of room to grow. and we get to make a lot of the calls ourselves here, even as the young team as we
About
are.
a year ago, Stream Chat.
So there's a big impact we can have on the future operations of this company.
Bro, I like the high-vis hoodies. Those are pretty cool.
Another unique is honestly is the people. It's you really see in every day how much they care, how much everyone comes here every day full of energy and passion, and everyone wants to do a good job, and they do.
Propane, Ramalot.
And then also working with all these smart and talented people who make this happening and are so driven by this mission to launch rockets and to produce them.
I love working in this area, especially because of the freedom that this job gives you in the amount of things you can learn.
What I love about working at ISAR is helping people working together towards a common goal, launching rockets.
I think we have the most amazing final product. Not a lot of other companies produce a rocket from scratch to the end.
The thing I like most about working in ISAR Aerospace is the fact that we are extremely ambitious and that we are able to learn something new every single day.
The unique character of ISAR Aerospace is the combination of ambition and responsibilities.
I love my job because every day is different. Many things happening at the same time.
The part that I love about working here is that you get to be a part of every step of the process.
Hell yeah.
What I like most of working with ISAR Aerospace is I'm allowed to travel a lot. So I meet people in Northern Sweden, Germany, and learn a lot about the cultures, and I have the best office view in the world, and look at that.
So Sci-Fi, this ISAR is German. They just launched it in Norway.
Positivity, focus and teamwork plays a very vital role into the work that I do and my team does on a general note.
And we truly are a team. So whenever I need help, I know I can count on my team members to come and help and get the job done.
I think the moment when I was most proud of our accomplishment was when I saw the software that we made being used during the launch operations.
I can feel the pulse is really getting high now as we approach to the second launch, and it's going to be really exciting.
There's one key thing that has driven me all of my life, and that's being part of a winning team.
I think it's been an incredible
Crane,
push from
crane,
the whole
crane,
company
crane,
to
crane,
get
crane,
back here
crane,
so fast.
crane.
As fast as we did in 9-10 months to get to this point, and I would say everybody is ready to send this.
I don't know if NSF filmed this. They may have.
That's always been something I've wanted to say, that I've worked on something that's gone into space.
Hell yeah. We all want to say that, bro. Absolutely.
I believe this company is able to basically make anything happen.
I don't know. That guy American? Huh. Dude, we got people from all over working for this company. That's cool. All right, guys. 38 minutes. Put up or shut up. Let's go. Let's do this.
Like you said, over 400 people, and as I watched the video, I've worked with some of the people there that are featured in the video, and everybody across the board is helpful. They want to solve problems. They're there to help you out when you need something. So
And it's really moving seeing that video, actually. Like seeing all this passion and dedication of all the people. That's what brought us to the pad.
You gotta love this stuff to do it.
It's not just a rocket. It's not just physical components or machines or anything like that. It's really the people behind the organization that drive it.
Exactly.
Outstanding.
Yeah, you might recognize that guy.
There are people from all over the world that work at ISAR. You could see the diversity there in the video. How many different countries are represented?
It's a very international group. I would say roughly 50 nations work at ISAR.
Okay. Yeah. And across the locations that you have a few different facilities.
Yes, and they all represent the fact that we're completely vertically integrated, right? We're spanning the entirety of the design process, building process, testing process, and launching process. And that's why we have also these different locations. So our headquarters are in Munich. That's when we do the engineering design.
Crazy.
And also production. We have a production hall.
Yep.
There is a test site, the ex-Kausche that I mentioned earlier, which is roughly an hour away from Munich. And then when it comes to full-scale testing of our engine, both development, acceptance, and qualification, we have our test site in the northern of Sweden, in Kiruna. And, of course, our launch pad here in the northern part of Norway, where we're standing today with our vehicle. At the same time, though, I have to say that we are in this process of scaling. I mentioned earlier, tens of vehicles per year.
Right.
And we can only do that with a production facility that can sustain that and can actually enable that. And that's also the reason why we're already moving this year to a new headquarters, still
nobody
in
does
Munich,
it better than him.
in the east part. And that's where we want to build Europe's first commercial serial production facility for state-of-the-art launch vehicles that enables this high cadence of tens of vehicles per year. And we actually see footage right now of this facility and its current status.
Nice.
That's a cool little time-lapse there of the facility being built.
It is.
So it sounds like you're going to need some help to fill this facility out.
Definitely. I mean, we're scaling up production operations, and to do that, we always need obviously brilliant people.
Guys, I see gantry cranes. Oh, I see more gantry cranes.
Operators. We need all these talents to scale up the company to the tens of vehicles per year.
I see gantry cranes.
Now,
I like it.
You don't just get to go down to the store and buy a rocket factory and then install it and let's do that 3 times and make some rockets. It takes a lot of work to actually build it, which is what we're seeing there.
It's going to fly north.
You have to go out and actually build your own factory. You can just buy it, and that's what we call the machine behind the machine. Our key focus is not just making this product work once today.
So
we
check
need to
this
show
out.
that it happens reliably and at a high frequency.
Go to next space flight,
and that's the part of industrialization
click on the onward and
integration. Actually, we can see footage of our current hull.
It's like a fly-through.
It is. It's a drone footage. It's a great video. We are right now in the additive manufacturing area. You can see some of the components for the engines
what's up, dude?
that are now being brought out of the printer.
Right.
Exactly. And then
I want
we're
one,
moving
Bandit.
towards the
avionics
lab.
Not
where
even kidding.
We have harness production
about it.
for stage 1, stage 2 of our vehicles. You can see that being laid out.
9 engines in the first stage, single one in the second. Yep,
We're continuing the tour. Oh, yeah.
In the bin, it looks like in the box.
So yeah, you get to see what
In the
part
bin.
that's being transferred now to storage and then to milling would experience. So you can see the automated robot there that just places it to the correct shelf.
So this is moving it around the factory. These are automated parts because you're trying to scale this up. You're not hand making one part. You want to make lots of parts.
Exactly. You need to automate as much as possible to get to this capability, obviously.
Wow. I do want to shake the hand of the drone pilot that flew this around. This is actually really cool.
It's really impressive work there.
And this is the current production hall. This isn't the new large production hall. This is the small. It's not small. The smaller production hall.
It's smaller. Yeah, it's definitely not smaller. I remember actually the original one.
Yeah.
It's the current production hall. I remember entering this hall maybe 6 years ago. It was an empty hall, like 50 times 50 meters.
Yeah.
I couldn't imagine at that point, to be honest, that it would be so filled
I got
with
a bench
both
grinder
machines and technicians, engineers,
I'm not
and
sure
also
what they're
vehicles,
doing here.
engine
Something
parts.
with that's
And now
probably
we've reached a
valve
point where we
testing,
do
guys.
need to get
A lot of
larger
they had a lot of
facility, roughly 10
argon,
times the
inert
area,
gas
actually,
for valve
just to
pressurization
get
testing.
this high cadence of producing the vehicles at the rate that we need.
Absolutely. I will say
CNC,
the big new buildings and stuff like that, and then everything
tank
that you've got here, plus
fabrication.
all the people. Sounds expensive.
Oh, this is freaking
How does all
sick,
this
dude.
get paid
Dude,
for?
look at that.
Well, our company
Hell
is
yeah,
privately
now
funded,
that's what I'm
so
talking
there are
about.
investment rounds through
Oh,
different
that's
stages
beautiful.
of the company that either
Very,
supported the development
very
of the launch
nice.
vehicle or as of recently the
Very
industrialization of the launch vehicle, meaning this.
Dude, credit where credit is due. Not everybody has the balls to just show their entire production facility like that. I mean, like, I really dig it. I'm not going to lie to you, and that's not just because my boy is over there. That's freaking sick, dude. I mean, who showed us the tooling? Vasta's done that. Relativity does that. SpaceX, now, you ain't never seeing the inside of those. No way. Now, Blue, some pictures here and there, right? But they're just drone shotting around their whole production facility. Dude, Credit where credit is due. That's really cool, man. ULA does it. Yeah, exactly. That's cool, man. I love it when they show the goods. That makes me so happy. I love the machine that builds the machine, right? Like, that's the best part, man. Well, flying is the best part, but you get the idea.
All of these operations that we said, from initial design, from scratch, to building, testing, launching, and closing that loop. Okay. And at the same time, in terms of the capabilities of the vehicles itself, so it's a multifunctional vehicle configured to offer a broad spectrum
the rocket
of
factory
so
must grow.
It was a natural progression of ending up with
Spectrum. It's almost like Spectrum Squared. There's like
That's
two
right,
spectrums involved here.
Yeah,
it's in Germany.
Excellent.
Yeah, and I believe it's in Munich.
We'll talk about these systems in depth.
Yeah.
But give us a rundown, like how big is the rocket? How much payload can it carry? And then we'll talk about some specifics like the structures behind it, the engines you've created, the fuel that it uses. Give us a rundown.
Yeah, very top level. I mean, Spectrum is a small to medium lift vehicle, meaning that it can bring up to 1,000 kilogram to low Earth orbit. It's a two-stage vehicle, propelled by liquid oxygen and liquid propane in both of the stages, and actually uses 9
it's
engines.
abandonware sci-fi.
Up in the lower stage.
First stage.
They shuttered the studio and sold
one
the
engine
IP.
vacuum optimized.
Don't buy it.
For the
Don't
upper
tell
stage.
anybody about it.
In terms of
Don't even think about it.
An idea, it's roughly 28 meters high,
Never been to
2
Germany.
meters in
9.
diameter,
9.
and
Never
weighs
been there.
roughly 55 tons.
Closest
when
I've been
fully
is
And you do all of this
Amsterdam.
in-house. Like, you want to not just build
Which is
one
not in
rocket
Germany.
or one rocket a year. You want to do this at scale.
Exactly. That's also the business model behind the company, building that
Cool
at
tech.
scale,
What do we got here?
reliably, frequently launching.
Mill?
Okay, we've switched to the CNC channel here real quick. So,
Yeah.
but again, all these machines in-house, parts being made, gives you some actual advantages to the work that you do. But
Very nice.
let's talk a little bit about the engines here. I don't need to guess. You just told me they're developed in-house.
They are developed in-house, so designed, developed, tested completely in-house. Yeah.
Tooling lathe.
For the propulsion fans out there, what sort of cycle is it?
So it's a gas generator cycle, meaning an open cycle. That was, in the beginning, when starting to develop the engine, it was very important to go out and test as many components as possible independently from each other, verify that they are set up to do the actual work they should be doing, and then putting everything together into an integrated system. So the gas generator cycle allowed us to do that using smaller scale testing without much of a coupling between the systems, and then putting everything together at the end. And also what was very important and ties together with the automation and industrialization part is having a single engine concept for both stages. So in terms of components, they're identical.
Dude, the snowy test stands are throwing me. I'm like, wait.
At different environmental conditions.
That's
but it was
snow.
very important to us to
I'm used to
use
seeing
the
test
number
stands in like
of
Florida
parts
and Texas
that only
and
have to
stuff.
be
I'm like,
produced once
wait, where's
for
the
upper
palm
stages.
trees?
If you can produce something 10 times instead of once, you can understand how much the cost can be driven down, how much time you save from having different designs, and so on and so forth.
Nick gets
so you hear about that sometimes, where the upper stage engine needs to operate where there's no atmosphere, right? In the vacuum of space as you sort of get going into orbit. But the first stage engines need to operate at sea level. They need to take off where the atmosphere, the air
snowy
that
test
we breathe is surrounding them.
It's got a
vibe
to it, huh?
Design two totally different engines for those two very different environments. But here, you've designed one engine that sort of fits both places, and you just tweaked it a little bit.
Exactly, yeah. Obviously, there are some tweaks that have to be done, but it was a requirement going into this design process to make sure that it's as similar as possible to the sea-level engine.
Gotcha. We flew through the 3D printing area earlier. Are parts of this 3D printed? You 3D print engines, I think, right?
Yes, we do several parts, both in the thrust chamber assembly, housings for valves, for example, for turbo pump components, are 3D printing. We leverage this technology because it allows us to iterate very fast. So we've seen some crazy iteration times in development testing, going from testing on the test stand to a new design, to printing, heat treating, milling, and then going back to Kiruna, to Sweden, to retest in a matter of a couple of weeks, which is extremely impressive. And it's enabled also, to a part, through the additive manufacturing component.
Gotcha. So we put together some engines. We need something to bolt the engines to, right? And that's where the composite structures come in.
Exactly. So structures,
gotta do this right.
Again, 90% of the weight of the Spectrum rocket is actual fuel, and this fuel is being held by the structures. What we keep saying internally is that structures have to be boring. Making them boring is not that easy, but essentially you don't want to start worrying about them. They need to obviously hold all the loads, and rockets experience a very harsh environment, both in terms of vibrations, in terms of static loads, accelerations, aeroacoustics, all these harsh environments, and that's the job of the structures to actually sustain that. And we have chosen linerless carbon tanks for our technology.
Linerless carbon tanks.
So carbon fibers, reinforced polymer, but without a metallic liner on the inside.
Probably saves weight.
Exactly. That's the main advantage.
Okay.
Obviously, as I said before, we want to have a design that is reliable and easy to build, but at the same time, we can't compromise performance of the vehicle. And by going with these carbon structures, we're ending up with 4 times better strength-to-weight ratio than other metallic materials.
Right.
And at the scale or the size of our vehicle, it does make a difference.
I mean, I've heard people say, oh, composite structures, they're so slow, they're so expensive. A lot of people seem to sort of think they're not great, but we've advanced beyond that. We're not talking about people with big flaps of carbon fiber that they're hand painting on the thing. You've got some automation here so that you can do this at scale.
Exactly. This is necessary, as you said, to scale up. So automated
Was that
winding,
a slight towards
placement
Rocket
of those
Lab?
fibers is necessarily what we're doing for the majority of the primary structures. And this is how you get to a fast pace of producing vehicles.
Right. And you said something very important there. For the scale of your vehicle, right? Yeah. The composite structures make sense because you can automate them because they're not overly sized, like insanely huge, the biggest thing ever, right?
Damn, dude.
They fit in this niche.
I'm pretty sure that's not what he meant, but also.
Yeah. If it was a different size, maybe we would have gone with a different technology, but for our particular size, it makes perfect sense.
Okay. So the fuel, I saw it there when we were at the pad, it said propane on the tanks real big, like propane like my barbecue grill uses?
Similar, probably not exactly the same grade.
It's not space propane, I guess. But
yeah, space propane. We need to make sure that the impurities are reduced, obviously, but other than that, it's the same chemical element, or it came.
Well, I tell you what, boy, that's some damn good propane.
That? I mean, I hear all these high-performance fuels or older fuels, or why choose propane?
Yeah. Well, we have to say that there is no optimal propellant combination that works globally for any single application. You've seen also launch vehicles with 2 different propellant combinations in 2 different stages. We're choosing, obviously, going with propane in both stages. It's always a trade-off between performance, your supply chain, your compatibility of the materials, availability. It's several factors. In our case, we found that propane has a high performance, especially when considering its high density. And the high density can be achieved because it has a low freezing temperature, meaning you can actually cool it down to low temperatures that are still compatible with the liquid oxygen temperatures and get this higher density from it. And at the same time, it also has an established supply chain, meaning that availability is not that big of a bottleneck when considering also the high cadence that we want to achieve.
Gotcha. That was a lot. That's why we brought the chief engineer onto the show here. You said compatibility with the temperature of a box. I guess that's the thing. Like you chill down the propane, and
so interesting thing, guys. He says space propane. Geek. All right, we want to talk shop talk for a second. It might be map gas. Seriously, all map gas is propane with a little bit more butane in it, so it burns hotter. Honestly, that's what it is. It's the mixture. That's the difference between like LNG, butane, and propane, right? Liquefied natural gas is a mix between methane, propane, and butane, and the parts, the mixture percentages is what denotes whether it's propane, butane, or LNG or liquid methane. I don't know if you guys wanted to learn about fossil fuels today, but there you go. They might be using map gas. It's possible. Like, I don't know. He didn't say, but engine bleed. Like when he says they might be using space like propane, dude, it might be map. Like the yellow bottle instead of the blue bottle. Right? You'd want the yellow bottle for your first stage. Just saying. You need to get that characteristic energy out. You got to get first stage has to be very energetic. Right? How much smaller or bigger is this compared to the average SpaceX rocket? Oh, this is way smaller. This is closer in size to Electron or Firefly Alpha. So the whole stack I would probably say is about maybe 2/3 the height of a Falcon 9 first stage. It's not a big vehicle, but it's not the smallest small sat launcher around either. We have 1 metric ton to orbit with this vehicle. So it's pretty big. It's bigger than Electron, but it's not as big as like Falcon. It's somewhat analogous in function to I don't know. I'd say Firefly Alpha would probably be its closest competitor in terms of like class for class capability.
for a second seeing
look
the
on the screen.
bleed.
Engine
really,
bleed.
really good to see that we're reaching this point.
Excellent. The clock continues to tick down.
So what that is right there, guys, is they're starting to move propellants into the 9 engines here. They do that to prime them. You don't want to dry fire a rocket engine. It'll explode badly. Very violently. So what they do is they move the propellants in. Now, once again, that's priming it to make sure that it's good to go, right? To make sure that you got a full tank of gas when you hit the go button. But also, it makes sure that the engines are getting down to temperature. Once again, they're using some form of liquefied propane and liquefied oxygen here. The rocket engine has to get to the right operating temperature. In this case, the turbine machinery, the fuel pumps need to be extremely cold to deal with the cold propellants. If you have a relatively hot fuel pump, right, and you shoot extremely cold fuel into your relatively hot fuel pump, like I know it's cold there, but it's not minus 200°C cold, right? If you take your minus 200°C propellants and shoot it into a turbo pump that's like maybe 5°C, that's still 195 degree temperature difference, right? That could evaporate your propellants, because the propellant's going to hit the relatively warm turbine machinery and then it's going to evaporate. That is what you're trying to avoid by doing the engine bleed. You do not want to evaporate the propellants inside of the fuel pump. What that can do is cause cavitation in your fuel pump. And if your liquid, operative word, liquid fuel pump gets cavitation, that means there's gases inside of your liquid fuel pump. Gases inside of your liquid fuel pump is a really nice way to make things catch on fire that you don't want to catch on fire. Yeah. So they're bleeding down the engines now to make sure that when they go to fire them, they're cold enough and they're also primed and ready to go. That basically makes it so when you go to turn it on, it actually turns on and stays on and it doesn't blow up. It'll go right to your thighs. And then you'll blow up, you know? Amazon Prime. No, it's not a Blue Origin rocket, Chuck. This is ISAR. It's different.
Industrialization and scaling very early on. We have a great manufacturing capability.
Kuro, I'm not streaming on YouTube right now.
Space launch ecosystem.
It's just Twitch. It's just you guys.
And all the capabilities that belong to it.
Kuka. Oh, that TIG weld though.
And so we ended up actually insourcing almost everything, or at this point we own about 90% of the value creation of the entire launch system.
Downcomer.
Which not only allows us to
There's
actually
your composites.
scale
That's the composite testing.
But it also gives us a lot of independence.
Oh, look at that freaking... Oh, that's mint!
The first step is...
Did you see that thing? It looked like something out of Portal.
Getting lots of new opportunities.
Amaze.
Now, if we want to develop a new system or upgrade the current system that we have the capability and the capacity to do so.
If anybody was wondering, that thing that was on fire on the right side of the test stand is it's called a percolation pond.
And into the skies,
yeah.
They don't just see the stars and
see there's the thing next to a car. It's pretty big. It's a pretty big launch vehicle for what it is.
Back here on Earth.
There in that video, we saw some of the automated fiber placement.
So what went wrong on the first launch? Sivola, okay. It's hard to make. All right, I'm going to try to explain this in kind of plain English. Like I'm not trying to be like condescending. The right way to say it would be it's hard to know how the rocket's going to fly in flight until you go and fly it in flight. You don't know how it's going to work, especially on a first try. You don't know how it's going to work on the first try because you've designed it to fly in flight, but you don't really know how it's going to fly in flight in terms of like vibrations, acoustics, guidance, until you actually send one. Long story short, their flight model wasn't the best that's one of those things that's hard to test. It's hard to, how are you going to test it? How are you going to test flight conditions on the ground flight, right? So sometimes you just have to go and fly the dang thing. So instead of trying to figure out a way to try and get their flight model more higher fidelity, they just launched one, and that gives them the data that they need to get a much higher fidelity flight model. Even 30 seconds of flight is a huge bit of data. That is a huge bit of, let's say, equity in the company. Getting a rocket to sequence off the pad and leave the pad correctly and then go up for 30 seconds. That is invaluable flight data to a company like ISAR, a newer company getting into it. That's flight data, man. Even if it did fail, right? Now you know what made your flight control systems fail in flight because you didn't know how the rocket flies. Now you know how the rocket flies, so you can mitigate that. That doesn't necessarily mean that you still aren't without risk, right? Where the rocket is operating right here at separation doesn't necessarily mean, that you understand your atmospheric model at higher altitudes or at max Q or at staging or anything. So this mission is still carrying a lot of risk. ISAR is going about that by mass production. They're just going to make more rockets. It's kind of the SpaceX approach. But let's say with a little bit of European pixie dust on top of it. Honestly, if I was running a company, I would be doing the same thing. I would be doing the exact same thing. If the first one blows up, so be it. I actually would plan for it to explode. Because you're running the balance between known unknowns and unknown unknowns, right? 17 minutes out. So think about it. You're a new company. Can you sit there? Can you afford to sit there for years and try to figure out every single possible failure mode for this rocket? No, you're not going to do that. You'll go bankrupt before you even get near the pad, right? Now, fortunately, we have entities like these guys right here that do stuff like that. So, when they go to launch, it works on the first try. SLS, a good example. STS-1, Space Shuttle. Good, right? Good example. Right? But when you're a small startup company like this, you can't sit there and do analysis all day. You can't do that. You're eventually going to run out of money. So these smaller companies, ISAR, Firefly, Relativity, when they go to launch, Stoke, eventually you got to send it. You got to balance your known unknowns with your unknown unknowns, right? At what point do you need flight data to retire the risk here, right? Because there's no guarantees that this is going to work. The big reason why is because the margin of error for, flying in the later stages of the mission, right? This company's never been there. It's not like they can go knock on Elon's door and be like, hey, how does a rocket fly in space? Right? Elon's going to be like, who are you? Right? Or it's not like they could go ask Peter Beck for advice. He's the competition, right? So you're with these startup companies, you are very much running the risk of an unknown, right? But also you can't sit there and try to solve every bit of the puzzle off the bat. If you try to do that, that's going to take years, decades. A lot of these companies don't have the margin to do stuff like that. So what ISAR has chosen is to beat the problem, try and address this problem with scale, right? That's why they showed off their factory, because they're addressing it with scale. Instead of sitting there and try to do all the analysis, to try and get the thing working, if you make more of these things, yeah, okay, so what? One fails. So what? Two fails. No big deal, right? You got another one. And most importantly, you have a gigantic factory that can crank these things out relatively quick, right? So if something does go wrong, that is a way to beat that unknown risk. It is very much iterative testing, right? Just like how SpaceX does it. It's the same idea, but I would say it's more iterative testing that lines up with like Falcon 9 rather than lining up with like how Starship is truly 100% iterative. Like if it blows up, whatever. You don't want it to do that, but if it does, oh well. Obviously ISAR's hoping for success today. They got to fly this thing's got to work. If you're choosing to do this way, there's only so many times you can fail before you're screwed. Like with SpaceX, dude, they failed 3 times in a row. They failed 3 times in a row, and then the 4th try, they barely got it, and then they got it, and look what happened, right? Like, even Falcon 1 was iterative to an extent, right? So, they're trying to beat that that balance of known unknowns and unknown unknowns with high flight rate. Now, a lot of people are trying to do that, but a lot of people don't have their rockets sitting on the pad ready to go right now. So, you know, take that into account. 13:37 on the clock. Lead
system. So
let's go back into Dawson, Nick. See what's
as well
up.
as operations are ready without any open engineering items.
Actually, so like I said, I'm pretty. All right, I'm just gonna say this as an American. This isn't my race. This isn't my, you know, like this isn't my space race. You know what I mean? This isn't my one of my American rockets from the United States. Blah blah blah. I will admit it's cool to see Europeans embracing this type of flying. That's super cool. That's a huge step for you guys, and dude, I'm cheering you on every step of the way. This is good stuff, man. This is what you should be doing, not what. Okay, I'm going to be more candid. Not what Ariane Space is doing. I don't know what the heck those people are thinking, but you know exactly what I mean. This is what you should be doing. Like, not, oh yeah, we'll fly 12 times a year. No. This. You should be doing this. This is a good idea. This is what you should be doing. This is how you build something like Falcon 9 eventually. Not, oh yeah, we'll maybe do that in the future. No. None of that crap. Stop that. Do this.
Months ago, we were actually standing on the pad, ready to go. One day prior to the intended launch date, we were standing on the pad and found actually an issue with one of our valves.
Okay.
As I said earlier,
like
we have high
dude,
standards, that being a qualification.
I'm cheering on you guys every step of the way. This is what you should be doing. This is good stuff, man. Good stuff. I really hope ISAR can nail it today.
And then be ready again a couple of weeks later to
exactly, Oculix. Yeah, exactly. Yeah. You're rooting for Ariane Space. It's like, okay. Geeson, I'm not touching that one. You guys want to argue that amongst yourselves? I'll be over here on my side of the pond, okay?
Seems like a good culprit.
It is also always the culprit, and it's kind of normal. They are, they have to operate.
That's right,
a large range of operating conditions and environments,
right?
temperatures.
Temperatures.
Exactly, yeah. And it's also complex parts in terms of their tolerances and stacking from a manufacturing point of view. And that's the reason why they're typically the culprit.
I like the umbilical shot here. All right,
I'm gonna make sure that we're caught up here. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Well, clock just went to T-minus 26. It went down from 11 to T-minus 20. The heck? Hold on. Let me get caught up.
But that's the propellants. There's probably some data, telemetry,
exactly.
Power.
So it's electrical and power umbilicals. It's fluid umbilicals, both for filling of our propellants and loading and unloading, for our helium loading and unloading. Essentially,
I missed the commentary for them saying why. Let me back it up.
Supports the rocket, and then also that just helps it stand up vertically. Here it's been retracted just a little bit, and all of the lines you can see sort of go. You sort of screen. That's the transporter erector, right?
You sure, Fox?
You use that to support the rocket as you roll it out from across the street. We saw that in the video.
Yes,
the AIT is across the street, and you sort of roll across, and that transports all the lines. I'm not going to ask you to do that live.
I think I could. But
probably could.
Also opened up, making sure that we can fly to our mission.
Right. Now, stand by, folks, for some more information. We did see that the clock has changed, but we will get an explanation as to what is going on here. Just please stand by as it continues to count down, but it did add a little bit of time there to it.
Yeah. So there are specific checkpoints across the procedures. We have to wait and see if it was an update based on some findings from the current operations.
Yep.
Why do it at night if
Today
it's a test flight? You lose so much complete imagery.
Control. We're letting them focus on their job.
Exactly.
I'm not sure, but they must be okay with that criteria, with that testing criteria, Pogo. I wouldn't do that.
As to that jump you observed on your screen, we will absolutely share it with you here on the stream.
I have to say it's also kind of weird for me as well. I'm used to getting this feed, getting a live view of the data. Yeah.
Nico wants to leave the stream so he can go get on his laptop and see what the status
is. Maybe you should.
But please stand by. We will get you more information as soon as we have it. So, again, if you're just joining us and you're wondering what's going on, the rocket you see on the pad is Spectrum. It's ISAR's rocket that they've built, and this is the second flight of Spectrum here this evening. It's almost said this afternoon, but it's not this afternoon.
This has 5 CubeSats on it?
things you see on the screen here, that's all pretty normal, right,
Most
Nico?
of them are
Exactly.
from
It's
a
normal.
bunch of
We're at the process
universities.
where we've already packed,
There's a
the
bunch of
vehicle.
student
Right.
payloads
It's
on
fully
board.
loaded at this point.
And one
both stage one and
ESA
stage two,
payload from their
both
boost
liquid
program.
oxygen and liquid propane. And at this point, since it's cryogenic liquids and there is some boil-off, we need to make sure that the vents or the vent valves are open in order to get all this boil-off out of the vehicle, not to pressurize it too much beyond its intended purpose, not to put any stress on it at this point.
Makes sense. Folks, we're going to pause the commentary for just a second and get an update for you. So please stand by. We're going to continue watching the vehicle, and when we come back, see if we can give you a status update on the current state of Spectrum for Flight 2 out here live from Andoya, Norway.
I had to guess, guys, they're targeting the end of the window because of temperatures. I'm not sure how much. This is a guess. This is totally a guess. I'm just putting it out there just in the off chance that I might be correct. And if I'm not correct, you guys can laugh at me later. It's fine. My guess, I'd be wondering how much data they have on tanking the vehicle at night. Obviously, it's colder at night. There's no big pulsating star up in the sky. And not, you know, like what you get during the day. That star does give off a lot of heat, even when you're in the Arctic Circle. Still, that's a major difference. So what could happen is if they've tested it at, like, say they've tested it when the outside
all right, folks, here's our plan for now.
temperature is 15,
We're going
and it's
to
not.
continue to listen into our headsets. We'll let you continue to see the views of the rockets. As soon as we get more information, we will share it here with you live. But again, all of these views are live from northern Norway. It's Andoya Spaceport up here. Spectrum on the pad. You can see that it's come to life even there on this. I love all of the shots. Every shot we change to. It's a fantastic shot of the rocket. But we will pause for just a second here and wait until we get some more information. As soon as we have it, we'll be back to let you know what the current status is of Flight 2.
So it's 2 degrees, or about 36 Fahrenheit in Andoya right now. I'd be wondering if, you know, if they've had prior tanking test. They just showed all their testing. All their testing was during the day. So think about it like this, dudes. If you have a nominal temperature gap, right, of like, say you have like 1 to 2 degrees for the proper temperatures that you need for your propellants, right? If it's at night and it's 2 degrees C instead of during the day, which would be at like maybe, I don't know, 5, 6, maybe 7 centigrade, right? That might be enough to throw a sensor, depending on your parameters for like upper limits of like how cool and how hot your propellants can be. So it might be because it's at night. And I know what people are going to say. Don't you take that stuff into account?
All right, folks, as promised, we've got that information.
Let's see.
Currently, right now, we do not have clearance for launch from the range. It sounds like there is a boat on the range right now. Something we've seen before, something we've heard about before.
Well, I'm wrong.
What happens at the Cape and things like that. But, of course, we clear the area, not only immediately around the pad, but downrange. This rocket is going to be going out over the ocean. And so there are areas where they want to keep boats out of. Just as
now
extra,
pause for station
extra safety
identification.
precaution, right? So here, lacking permission from the range because of that boat violation, a range violation, we are currently in a pause, seeing what the path forward will be. Right, Nico?
Exactly. As you mentioned, flying downrange, we need to make sure that all the safety precautions and regulations are being held. And that's why we have notices for NOTMAR and NOTAR, so both marine and air traffic. And apparently there is a violation, as you just mentioned.
Yep. It's a good way to keep up with launches because this information is published
Andoya
to the
means
public.
Duck
There's
Island.
fishing boats out there, right? There's folks who are
Cool.
working out there, and
I don't see any
we
ducks,
need to make sure
though,
that they have the
Gastro.
information.
What's
We
that
don't
about?
just go there on the morning of launch and say, "Oh, by the way, you can't be out there tonight." This is published days or weeks in
Yeah,
advance.
that's right.
There's multiple different places where the information is made available to mariners and the general public. But here again, to repeat,
Borg.
we are currently standing
Try to keep
by.
it
We
try
do
to keep
not
it classy
have
during the day,
permission
but
from
dude,
the
I think it's
range to
warranted
launch
this time
due
around,
to
so
a
I'll allow
boat
it just this one time,
violation
dude.
on that one. We're going to come
Frickin'
back
boats,
with more
man.
information in just a second, so continue to enjoy the rocket views, and please stand by.
So yeah, okay. It looks like they took in the temperature variation into account, which is great. Yeah, that was just a guess, dude. That could be a bunch of different things. But yeah, boat in the range was, I would say out of all the things that could push the launch, boat in the range was definitely in my top 5, but that wasn't the first one that I would have guessed. Because who's out there in the water at night, you know, up in the Arctic Circle? But also, clearly somebody, so we're at 19 minutes and counting. We'll see. Oh, I'm sorry. I wasn't aware your daytime crowd is an 18 plus. It's all good, brother. Don't worry about it. Sometimes, you know what, man? Sometimes you just have to frickin' say shit. It's okay. Just try to dial it back a little bit, okay? Like during the day. At night, swear like a sailor. I don't care. Because I can tell you right now, if I was the mission director for ISAR right now and the range came back and said there's a boat in the range, that's what I would be saying. I'd be like, you melon farming, funkin' waggling piece of doo-doo. Just like that. MacB, what's up, man? Well, crap. I mean, South Harmon Institute of Technology. Yeah. With that tone of voice, yeah, right? What an odd thing to say. It sounds like me around my 5-year-old. You funkin' waggling piece of melon farming excrement. Or something. From what I see, it's not a farmer, just a private yacht. Okay. You still have the bleep button. I don't when I change setups, Crylox. I have to retool that back into Streamlabs, but yeah. Chris Kemp threatened legal action against a boat in the range once. Okay. Yeah, Vanta, that reads. Yep. Does the boat legally have to move? I would. Well, the boat is violating a temporary NOTMAR, notice to marine traffic. So, yeah, you're answering to the government of Norway right now. So, yeah, I would say if the Norwegian government was like, you need to move, I'd probably move. It's just like, you know, if you're down in Florida and the Coast Guard came up, you know, knocking on your doorstep, you know, they pull up next to you. Hey, it's us, the Coast Guard. What are you doing? Please move. You know, hey, it's us, your friend, the Coast Guard. You know, get the hell out of here. You know, pick the boat, drop the stage on him for all I can. Yeah, yeah, we probably shouldn't do that. Probably shouldn't. Oh, bro, this multi-view is sick, though. 16 minutes and counting. I doubt they say please. Yeah, they don't. Actually, they'll radio you. They'll radio you on a blanket frequency and be like, "What are you doing? Get out of the range." And if you don't have a radio, then they're gonna send somebody. First of all, if you don't have a radio out on the water, you're an idiot. Second of all, if you don't have a radar, you're also an idiot. Not saying that that's what's going on, but also don't go out into the ocean on a boat without a radar and a radio. It won't end well. Well, a buddy of mine was in the Coast Guard, and a civilian boat pulled alongside his cutter and started tossing bags of lobster to them. It was Jimmy Buffett, so they let him. That's fair. Yeah, that's fine. That reads. It's like driving at night without lights. Yeah, yes, exactly. An anonymous gifter gifted a sub to Going Fishing. I love it. That's awesome. Gone fishing. That's probably what it is, dude. It's probably a dude out there fishing. I bet you, like, I'm not that big of a seafood guy, but I'll bet you the fishing's real good up there. DYs and DOS know how to do camera setups. Oh yeah. I would say that's mostly D. The good stuff. Ironic, the boat name is Cosmos. No way. Can't make this up, dude. You can't make this up. Can't make it up, man. I don't think it's a fishing boat, Cryolox. Baz, what type of ship is Cosmos? Is it a fishing vessel? Send a Viking longboat after them. All right. It is a fishing boat, Yannick. How big is this launch site? Zizep, I'd say about the size of a soccer pitch, man. Or a football pitch for you guys. Your football, not Patriots, not our football. Our football. Hand egg. It's not, yeah, about that size. It's not very big. This is not the biggest rocket, but it ain't the smallest rocket around either. This is bigger than Electron, guys. Yeah, I know it looks to be about the same size, but it's a little bit bigger. It's about comparable in size to Firefly Alpha, I'd say. Oh, nice, Fluffy. That's cool. Who is ISAR? ISAR Aerospace, Newmark, is a European commercial launch provider out of Munich, out of Germany. München. This is their second launch. Their first launch didn't go well. It landed in the water over there. They're going to try again here, but unfortunately they had a little bit of a delay in the count because there's a freaking boat in the range. Patriots is not our football either. Well, it's my football, and that's all that matters because it's my stream, NX. You get 6 Super Bowl rings, your football team can matter too. Unless you're the Steelers, in which case, yeah, all right. Good point.
Oh, this is space. I'm in space.
Jason gifted a sub to bad fishing boat. All right. All right.
Folks, another update for you. You've noticed that the clock has continued to tick down. We are waiting for the range to clear. A little bit earlier, we mentioned that the range was currently in violation. There was a boat on the range that was preventing the rocket from launching. Nico, that's got to be frustrating. The rocket isn't ready.
It is. The vehicle seems to be ready, loaded, ready to go, but this is now out of control. Let's hope that it gets resolved as quickly as possible.
And absolutely important for public safety as well.
Yes, it's definitely a precaution that is necessary. But still, it's something right now that we wish wasn't there.
Yep. So, since the clock is continuing to tick, let's continue to talk about the mission here, shall we?
Yeah, we can do that.
All right. So far today, we've been preparing this rocket for launch. And
no, let's
so
not Black. Let's get out Black. Let's get out of here.
Let's talk about some of the milestones, the fueling, all the things that had to happen to get us here where the rocket was ready to go.
So only Steelers fans could talk crap. Everybody else, you can join the scrub club of not having 6 Super Bowl rings, right?
With a transporter erector, all the umbilical connections are being done.
I want to watch
all
the
health
rocket.
checks
Leave me
are
alone.
being done on particular systems like the fluid system, on valves, on structures,
91.
on avionics, on propulsion. And then comes the launch day, which started today. It was an early day, maybe around 11 a.m., 11:30 is when we started rigging the pad, making sure that everything is prepared. And then there are some milestones along the way. Obviously powering on the electronics, making sure that the onboard computers are reading as they should be. They have all the health checks passed. Then again, doing.
So, guys, at 10 minutes on the Twitch side, well, not on the Twitch side of things, only on Twitch. At 10 minutes, I'm going to run ads. Actually, I'll just run them now. The idea is, so if you're not subbed to the stream, first of all, I don't care. I'm just happy you're here watching. If you are. If you're not subscribed, I don't want you to get ads during the launch. So I'm going to run those pre-rolls right now. Sorry, I hate ads. If I had my way, I would never run them. I don't believe in making money in content creation that way. At least for a live stream. VODs.
Discovery, go at throttle up.
So, I'll see you on the other side. Astrodeca, 4-month resub. Thank you very much.
Would expect for them to ignite properly and have their nominal behavior. So this is the purpose of this bleed coming off the side.
So you don't want to surprise them with a big temperature change. You don't want them to be a sort of ambient outside temperature and then all of a sudden
Tier 1 6 months in advance. Thanks, man. That really helps me out. I appreciate it.
Yeah, precondition them and also make sure that the fluids themselves get to the turbopumps when they get
36
to the
Ajox,
chamber,
22-monther. Thanks, guys. I appreciate it.
Are within the nominal range of temperatures that we accept, to also ensure that the performance
inside of 10
of
minutes.
the engine is going to be as we test it on the test rig and as we test it in stage testing.
Makes sense.
Yeah,
So
don't worry
I'm
about it,
gonna
dude. I hate ads. I can't stand them.
Stand by.
Discovery,
I just got the call that we are preparing for auto sequence start. We just crossed
here we
13
go.
minus
Prop
10
start.
minutes. Let's manifest some positivity
Blue Origin
here.
is paying for
I'd
this
love
sub.
to see
Great news.
This
Very
launch,
happy
but
to hear
again,
All right.
if the range does clear,
Lovely.
as the rocket continues to count down, let's talk about what we would see after engine ignition and liftoff.
Snarfer with the 25s. Oh my goodness, dude. Thank you so much. Bro, you're too kind to me, dude. Dude, I gotta put the car together. You already gave enough cash for that, dude. Don't worry about it. But dang, man. Thanks for caring. Of course, man.
Over GNC.
I'm a content viewer before I got into content creation. I still watch streams, YouTubes. That's all. That's what I do. It's fun for me. So I totally understand the end user side of this stuff. I freaking can't stand ads. I hate them so much. Anyway, Intaris, thank you for the 79-month resub. Let's get back to them talking. I don't want to make it about that.
So we have liftoff.
Gotcha.
So when do you have time for that?
It starts the engines up before it's released for flight to make sure the engines sort of settle in, I guess you could say.
5 to 6 hours of sleep a night.
You can also open it without having thrust. You need this push from the bottom to propel you at this point.
Right.
And that's where we have a liftoff.
Buffalo!
In the first phases, right after liftoff, we have a
gifted 5 subs. Thank you. SG71, 7 months. Thanks, man.
Which is then transferred into a pitch over, or rather getting from vertical to horizontal, because that's what we need at the end to get into orbit.
Yeah. You'll notice at the bottom of the image there was no boat on the range.
Yes.
Which is why we're able to go into the animation.
8 minutes.
Exactly.
Postal gifted a sub to Ab Lover. 3LRD gifted 5 subs. Thanks for the sub train, guys. Holy crap. Just look.
On our structures, we're still.
I appreciate it, dudes. Make sure you go support NSF with this stuff too. At least give their YouTube channel a subscription. I'm not asking you to buy the merch or anything, right? But you know, they're the ones that DOS is the one perpetrating this content, you know. And I thank God I have permission to restream it. So if you're supporting me, I appreciate it. Make sure you go over there. See if you can support your boy. They do a good job. But yeah, thank you so much, guys. I appreciate it.
That's the definition of space, essentially. And after some point, since we've
thank you for all the bits and subs, dudes. You guys are too nice.
We have fairing separation, so the payloads
they
are
do,
exposed.
I do like NSF merch. The Richardson 112 hats, you can't lose.
And
this is a Richardson 112.
Burning,
the best hats
it's
around.
Be roughly 5 minutes of stage 2 burn time before the so-called SECO, that second engine cutoff. This is when
it's good to hear
actually become orbital,
in the Twitch world
but
again,
we're not in the final orbit yet.
At least if it's through me, it's by proxy.
Right, to wait for roughly half an orbit. It's approximately an hour. You can think of it going once or halfway
around the planet.
Halfway around the planet, exactly.
I make jokes,
and that's when we do
so I tip the band.
Burn.
Love what you do.
Pulse,
hey, be sure to tip your waitress too.
In the order of space. And with that, we are placed in the final orbit.
Dino gifted 5 and Maddie gifted 5. You guys,
some seconds later,
so much.
We release the spacecraft into this dedicated orbit.
This is space. I'm in space.
I'm happy that you guys are on the same page as me there. We all hate, and we can all hate ads together.
A deorbiting burn. This is where we flip essentially the stage over, do another short burst, and with that we reduce the velocity and allow it to safely go and enter into the atmosphere.
Back into the atmosphere.
Thanks,
Being a good space citizen to make sure you don't leave orbital.
Yeah, they're doing a deorbit burn. That's a complicated mission, guys. Let's see if they can do it.
In orbit.
Again, if you're just joining us, I know more and more people come and join the stream. The closer we get
companies
to
got to pay us to do
the
that,
latest
dude.
information we had was that we did not have clearance from the range to launch.
Dusty and
there was
Brady
a
and
boat
the rest
on
of the
the
crew,
range.
Kevin.
This is very important.
This is what they're doing all the time,
that when
man.
we launch these rockets, we want to see the
But
flight.
people
We want to get the
gotta
data,
want this
but we also
services,
want to
and I
make
think
sure
the
that we
services
follow
are
all
good,
safety
man.
protocols. We keep the public safe. We keep the people that are working out there on the boat safe. So the latest information was that there was a boat on the range that was going to not allow us to fly. However, the clock is continuing to count down right now. So we are going to continue telling you all about the mission as we've just crossed under T-minus 5.5 minutes. And as soon as we have any more information, I believe the hope is that that boat is able to clear out of the range right here as we get down. We'll be safe, we follow the safety protocols, but there still is a chance.
Hopefully
we get the
ISAR
rocket
can say,
off the
I'm in
tonight.
space. I'm in space. In about 15
Manifesting
minutes.
the positivity here.
You think they'll see it?
Okay.
This is space.
We
I'm
are
in
now
space.
less
I mean,
than
look
5
north,
minutes away
Arglu.
from
You
launch.
might be able to,
There's
dude.
going
If
to be,
you're
of
if
course,
you're up
I imagine
there,
there's
I
lots
think.
of conversations
Where are
happening
you,
in mission
Trumso?
control right now.
You might be able
I
to see it,
can
dude. It's possible.
hear some of the operators.
Friend of monkeys.
Or imagine them.
Thank you.
At this point.
Amazed.
I'm sure that the pulse is also pretty high for all the operators. It's also a situation that we experienced for the first time. You know, something also outside
Somebody
of
gifted a
control.
sub to stream ads.
You know, we've dealt with unexpected situations in the control room before, technical issues,
Mickey
and
Stennis.
so forth, but
With
you know,
that
I
prime
think this is
sub.
the first that we
Thanks,
have this
man.
range issue at this moment.
Yep. And it's all about getting experience.
4 minutes, 30
experience with
seconds.
the rocket even tonight, your team is getting experience
You're
on
southwest an
how
hour
you
drive
deal
from
with
Tromsø.
launching these vehicles, but also making sure that you follow all
Maybe.
proper protocols
I mean, look,
to
dude,
maintain
look
public
north.
safety.
Actually, you would want to look
Absolutely. So we will
northwest,
continue to
slightly
see
northwest.
if we are able to get
so, like,
that range clear.
If you were looking at on a heading on a compass, probably like 315, between 315 and 360, look in that direction. That's where she's going. She's going sun synchronous, but it's sun synchronous on a northern trajectory. So if you're flying sun synchronous, like out of Vandenberg, for instance, you would fly southwest. Okay, sun synchronous out of the northern hemisphere. Well, not the northern hemisphere. Out of on a northern trajectory would be northwest, because they need to insert into a 97-degree inclination for sun synchronous. That's where this thing is going. Yeah, 97 degrees, slightly retrograde. So that's why I mean look northwest, like probably 315 to 360 on the compass. You should be able to see it. I mean, if you're up north, it's possible. You'll probably see it low on the horizon. And if you're by the ocean, it makes it a lot easier because, you know, there's no trees or mountains in the way.
To say, because it looks to me like Spectrum is ready to go. If I
Delta V higher on this launch, actually, Huzzah, from a more northern latitude, a polar orbit's actually easier. It's less Delta V to get into. Yeah, because you don't need to take into account the Earth spinning like crazy at a higher or lower latitude. Or, well, higher latitudes. It'd be higher latitude on both northern and southern hemisphere, right? Because that's how latitude works. Yeah, it's actually less Delta V to get into sun synchronous from a higher latitude launch site. Star for gifted
Folks, an update here at 2.5 minutes to launch. I just got word in my head that we have clearance from the range to launch.
All right, baby,
the range has been cleared, and we got the go that we are able to give it an attempt here. So,
all right, I'm gonna just fast forward, make sure we're caught up. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. Just make sure we're in line. Here we got 2 minutes. Yeah, we're a little bit behind. Okay, here we go. We're caught up. T-minus 1 minute, 45 seconds. T-minus 90 seconds and counting. T-minus 1 minute.
T-minus 60 seconds.
I said it better, Das, all right? Jeez.
The auto sequence has started.
Okay. ISAR has now enabled the auto sequencer on the Spectrum rocket.
45.
T-minus 30 seconds.
T-minus 30.
$20 seconds.
T-minus 10. Let's go, Spectrum.
2, 1, hold. Oh. Computer caught something. Oh, sound suppressor turned on.
Folks, there at the end, you saw we have crossed the T0, and we did get the call that there was an abort at the last second. This is a normal thing that happens. As we were waiting for the rocket to go, we're going to get a little bit more information for you here, but this is a thing that can happen. Remember what Nico talked about, the different safety checks that happen right at the end, right before launch.
Yeah,
it
but they
sounds
hose
like
down the
didn't
rocket
quite
with the
get there.
suppressor.
I'll get you more information
Titan's
as soon as
good.
I have
he popped
it.
in
Please
right
stand
at the
by.
last second. I'm like, no. Oh no, our rocket, it's broken. Please, Vulcan, help my rocket. He is very sick. What's up, man? 75 months. Ah, that's not what you want to see, dudes. It looks like the computer's caught something. So, but usually with rockets, right before you go to launch the thing, like in the last 5 seconds, the computer will do a final check on everything, and it caught something. It could be anything from like an engine temperature not being right to not the right pressure in the line. Could be range. Unlikely range given, circumstances prior. Yeah, it's hard to say. It could be a bunch of different things, dude. But
folks, we are standing by here as soon as we get more information from Mission Control. It's important to me. I don't want to guess as to what goes on here. I mean, Nico is back with us. Nico, so many different sensors, so many different leads, so much different information. There's a lot of different things that could be happening right now.
Yeah. At this point, we don't have any precise information as to what exactly the reason for the abort was. But
yeah, it was right before ignition, 3LRD. That's my guess.
So we need to ensure that all the systems
Flavia Titan's doing just fine.
Are within their required envelope to proceed with flight. So that being tank pressures, that being COPV storage pressures or helium gas pressures.
Right.
Shortly before going into actual engine ignition, we want to make sure that the rest of the system is in a good health to also ensure that we don't have another cycle on the engines themselves. Now we can only speculate what the exact reason was, but one thing is for sure, it's always a fine balance of making sure you don't have too many checks, but still enough to ensure that you can go on with the vehicle for a successful mission.
Right. As soon as we get more information as to the cause of that abort, we will be back and share it with you. But Nico, you're exactly right. We are not going to sit here and guess about all the different things. Remember, 100,000 different things have to go right in order for the launch to occur. One thing might have been out of bounds, and we'll get you more information on exactly what that was as soon as we can. We might not get it right now, even.
Yeah.
So, again, if you are just joining us...
I want to see it. I want to see what happens.
T-10.
Let me listen.
Let's go, Spectrum.
Let me see.
Let's go, Spectrum. T-10. Let's go, Spectrum.
Right when Das said that, the vehicle... So, it is an abort at 3. It's an abort at 3. They brought the tanks down from flight pressure. The control systems are working right here. Guys, what I'm kind of worried about is they sprayed the bottom of the rocket. The deluge system turned on. Watch. Watch. Oh,
folks, there at the end, you saw we have crossed the...
That's not great. You really don't want to do that. Yeah.
T0.
Yeah, that's yeah, see the rocket's got water. Dude, it's soaked. Oh, yeah, that might be all right, but generally no. You do not want your rocket to be soggy like that. Now, don't get me wrong, is the outside of the rocket designed to get wet? Yeah. Of course, it's got ice all over it, right? But down there, not so much. The heat blankets and stuff that the rocket engines are attached to, the thermal protection systems down there, that stuff you generally don't want getting wet. And I know people are going to say, EJ, this rocket ain't reusable. What do you mean? What do you mean thermal protection systems? There is TPS on any rocket that flies down the bottom here. It's this stuff. So the bottom of these rockets generally are made, there is some type of thermal protection system down here because you're in an aerodynamic dead zone on the way up. Stuff gets stuck in between, like heat energy, well, just heat gets stuck in between the rocket nozzles and stuff, and it scorches these blankets and it scorches the bottom of the vehicle. You can actually see there's some evidence of that happening right here because from when this vehicle was tested. Yeah, this is the kind of stuff you don't want getting wet. Because like I said, when the vehicle goes up, there's there's drag, aerodynamic dead zone happens down here because the air that's flying past the rocket just keeps going. It keeps flying past. And because the rocket engines create a vacuum because they're accelerating the air from, what is it, the Coanda effect, right? You get extremely low pressure in here, and the bottoms of most of these rockets get scorched. If you look at like New Glenn when it's come back, you look at Falcon 9 when it's come back, that's exactly what I'm talking about. The bottom of the things are cooked. Even a rocket that's not reusable on the way up, you still need to have some heat rejection out here. Well, some passive heat rejection systems. And basically you need a thermal protection system down here. The one that just got hosed with water. Yeah, these blankets and stuff. I don't know if that's okay. You know, whether you'd want to let that fly actually or not is really up to the engineers. Yep, they scrubbed.
To determine what the issue was this evening and see what we have for upcoming launch dates and windows as well. Nico, as always, it's fantastic here being with you talking about rockets.
It was great being here. I'm looking forward to getting here as soon as possible again for our next Flight 2 attempt.
Absolutely. Folks, Nico Parakis, Chief Engineer for Spectrum, thank you so much for joining us.
Thank you, John.
All right. And again, folks, say thanks to ISAR this evening, giving us all the fantastic views of the pad. The drone shots were fantastic.
Oh, yeah, they were
both
spectacular.
Inside and outside of the factory. I know that we all wanted to see a launch tonight, but you'd rather be on the ground wishing you were flying than flying wishing you were on the ground. And tonight, we've aborted the Flight 2 for Spectrum's launch attempt. I'm John Galloway with NSF. We appreciate you watching, and we will see you for the next attempt of ISAR's Flight 2.
That's not what you want to see, man. That sucks. But once again, you know, looking at this positively, every scrub, every hold, every time they sequence the count on this booster, there's something that's new data to add to your data set, and that's what really matters, guys. It's not what you want to see, but hey, it didn't blow up. That's a positive. Last time they tried this, it blew up. It didn't blow up this time, so that's good. I mean, you didn't get what you wanted, but it didn't explode, you know, so positives. Got to look at the positives, man. Yeah, they didn't cycle the engines. Yeah, once again, I'll bet you that the deluge system turning on is what hosed them. I don't know why that wouldn't be tied to your auto sequencer. Yeah. Pun intended. So yeah, they did unfortunately have a scrub, and that sucks. I'm going to go ahead and guess it was because they hosed down their own rocket. That's not really what you want. But once again, I bet you they won't make that mistake again. Watch. So what happened here is the auto sequencer caught a hold at T-minus 3 seconds. It saw something it didn't like. Could be temperatures, could be pressures. Whatever sensor data is getting relayed to the flight computer, right? If it sees something it doesn't like, oh, that's at 2 degrees Celsius and it should be at 4. Just random example, right? It's going to say no. It's going to reject the launch. Think about it like if a pilot's going down a runway, you can accept the launch and take off, or you can reject it and just roll out on the runway, right? I mean, once you get past a certain point, you got to go. Obviously, that's planes, but you can reject the takeoff. The computer rejected the launch. It happens. It does happen, especially with new rockets. That is not anything out of the blue. All the engines usually start at -3. Yeah, Geek, if you didn't have good pressure in your COPVs to spin start the engines, or you didn't have good helium pressure for tank ullage, there's 1,000 different things that could be. I can guarantee you, with reasonable confidence, I can tell you that it's something with the first stage. It caught something with the igniter, with the ignition, the ignition process. It saw something it didn't like. My big thing, though, dudes, is that they activated the deluge system and they hosed down their own rocket. Now, I know, guys, when you know, if you've watched rocket launches in the past, you've seen them fly, and it seems like they hose the pad down with water. Like, yeah, they have, but it only seems like they hose down the rocket with water. Usually the deluge system, actually, it's top side of the launch deck, so that's a sound suppressor. Usually the rocket's gone by, It's gone past that, and then it shoots its exhaust into that water plume that comes out over there. The reason why it does that is to make sure sound doesn't reverberate off the deck of the pad and destroy the vehicle on takeoff. Yes, you heard that right. Rockets are so ridiculously loud, they can actually shake themselves to pieces during the like terminal phases of like ignition and liftoff. So like in the first 5 seconds, you can get sound reverbing off the ground. So they shoot water all over the pad. That water system was supposed to go off when the rocket was already gone to protect the pad, but it didn't. So they ended up hosing down their own rocket with water. Once again, is that a problem? Yeah, see that right there? Is that a problem? Yeah, I don't know. Probably not. Would you want to check the vehicle again before you do that? Yeah. Yeah, I would. Yeah, I would go in there and at very least do an inspection. Just to make sure that everything down there is honky-dory. Because, yeah, you just hosed your propulsion system with water. I would take the vehicle off the pad. That's me, though. I don't know. Like, I would take it off the pad. I would roll it back into the hangar. CSI Starbase's latest video covers that really well. Yes, for Starship's pad. That's right. Zach did an amazing job with that video. NSF tweet. What are they saying? Better safe than sorry. Yeah, absolutely. You know, guys, here's the other thing is that if this is like their 15th, 20th launch, 100th launch, this shouldn't be happening right now. I would be a lot more critical. Like, because you shouldn't get to 100 launches and have something like that happen, right? That would be a big problem. But it's the second launch, dude. And these guys started from scratch. They started with nothing. And that does mean a lot. That's hard to do. And you're not going to know. There's a lot of unknown unknowns. I talked about the balance between being an aerospace startup and unknown unknowns, right? You know, you could put one rocket together. That don't mean it's going to work. You're not going to know if it's going to work until you send it. You could sit there and bookworm it all day to try and prove mathematically that it's going to work. But by the time you get all that analysis done, you're going to have no money left. So you have to find the point of doing good enough analysis and then corroborating that with flight data and sending it. ISAR is trying to find that nominal gap, and I think they're honing in on it pretty well. But yeah, this stuff happens, dude. Because it's second launch? Yeah, no, it's totally normal. Totally normal for the computer to catch something you don't want. You really want to make sure you're on your game for the first couple of launches. You don't want any surprises here.
Discovery,
hey, Slackster.
throttle up.
61-month resub. Let's see. What is NSF saying? Oh, no! No. No. H. Biglin with the Prime sub. Thank you very much. Oh, no. Oh, no. Let me check the back channel. Hold on. What are they saying? Oh. This is good news. I might actually make a visit to Ndoya and watch it. There you go. But see, yeah, hosing down the rocket, man. I would take it back into the hangar and make sure that that thing's okay. Sink that boat. So, a little bit of clarification, guys. It's not, this is because they scrubbed, there was an abort, all right? So, just from NSF Actual, the boat got in the range, it delayed the window, they went to launch the rocket in the later parts of the window, and it auto-aborted. So, the boat wasn't the cause of it, even though I'd say by proxy, yes. Yeah. There's a lot of fishing and recreational vessels in that area. Somebody must not have gotten the memo. Yeah, from what I'm hearing, and this is, guys, so, all right, if you don't know me, NSF, the company that produced that, I work for them. I work for them, and I have access to the back channel, and I can say this. I just made sure that I could. Yeah, it was an abort that was separate from the boat in the range thing that delayed the launch. The abort was separate. So they saw something on the rocket that Spectrum's onboard computers saw something it didn't like. That's what happened. So next launch attempt tomorrow. Honestly, drummer, okay, so if it was me, I would take that rocket off the pad. I know it sucks, but you hosed down your propulsion system. Your main propulsion segment on the first stage. You hosed it down. First and foremost, you got to figure out what flagged that auto abort, right? Obviously. Then I would go look at the engine section just to be absolutely sure. You don't want to play games. You don't need another failure, right? Obviously, and the way that I've been taught over the years to deal with this problem is, well, go look at it. Is it wet? Should it be wet? No. If it's not wet, fix it. Make it not wet. And then put it back together the exact same way you would before it got wet, right? Just to be absolutely sure. You don't know what they hosed down there, man. Like, it's not just the thermal protection systems at the bottom of the vehicle, dude. The whole engine section, umbilicals and everything got hosed. If any of that is made out of steel or something, it's going to rust. I mean, even, sir, it looked to be mostly stainless down there. Can I dry a rocket in the microwave? I probably wouldn't do that, but, you do you, boo. I'm trying to get a shot. They had a shot of the umbilicals there, and it was really, really nice. Where is it? Trying to see if I can find a picture of it. Here, let's flip back. Just perform a static fire to dry it off. Yeah, what if you wet something? What if you wet some electronic system down there? And it shorts out and you go to launch it and it blows up. Or you go to test fire it and it blows up. Nope, got to take it apart. That's what I would do. Now, guys, like, once again, if this was the 100th launch and you have a lot of good flight data, yeah, sure, don't worry about it. Send it, see what happens, right? But it's the second launch. You don't want to play games right now. Don't do anything that's not exactly what you should be doing. Or like what you intended to do, I should say, is the right way to say that. Where's that dang old shot of the umbilicals? So once again, if you're just joining us, the ISAR with Spectrum launch unfortunately did scrub. That sucks. A boat in the range and then an auto sequencer abort was caught. Maybe here? Nice shot of the second stage test article. I like the truck. There we go. What do we got there? What kind of truck is that? Volvo? Yeah, that reads, given this part of the world. I know that Volvo is Swedish, not Norwegian. For the love of God. I'm not trying to piss off any Norwegians when I'm here, okay? Not much, at least. There's the shot of the umbilicals. So see all this? That all just got hosed. All of that got soaked. Now, if you want to run, if you think it's fine, send it. But I wouldn't. I'd take that thing right off the pad and check it. Or Swedes, for that matter. Screw them. Yeah, see all this stuff? All these umbilicals that are supposed to be out of the way before the water sprays on the pad. You hose down your hold down points. Like, the hold down points are probably okay. I wouldn't be too upset about the umbilicals getting wrecked because that's what they're supposed to be under the water stream, so they get protected. So they are going to get a little bit wet, but the vehicle is not supposed to be wet. Think about it this way. If you had, say you had a Cessna 152 and you bought this Cessna 152 and the previous owner thought it was a seaplane and drove it into the water and the whole plane got submerged, right? And then you pull it out. Well, the plane looks okay, right? It looks fine, but it's been underwater. Would you fly around in that plane? No, absolutely not. I would throw it in the trash, if you really want my honest opinion. I'm not risking my life on that. That would be a really stupid thing to do, right? Now, in this particular case, no people are on board this rocket, but would you want to risk it? That rocket is not cheap, just like the Cessna. It's actually the rocket's way more expensive than the Cessna, but you see what I'm saying? Don't do that. That's what I mean. And once again, I'm speculating. I'm very much speculating. If I was on the professional cast, I wouldn't say nothing, right? But honestly, yeah, the deluge went off and hosed the entire bottom of the rocket. I would take that off the pad, like right now. I wouldn't. Yeah, there you go, Dan. That's what I mean. You don't know. It's not like whether it's going to be a big deal or not. You don't know. And that's introducing another unknown into an already risky flight. You don't make it harder than it needs to be, right? I'd sell that plane to somebody else. Yeah. Yeah, I'd be like, yo, it's been in the water. I don't want this. Actually, Drummer, you know what, dude? You asked me in the back channel. One of my moderators actually has a question. For like an orbital class launch vehicle, right? You have your sound suppressor, you have your pad deluge. Drummer actually asked a really good question. Drummer, I don't know if you want me to say this on stream, but it's a good question anyway. So how does you asked how an ICBM silo works? How does an ICBM have a pad deluge system or a flame diverter? The answer is yes, absolutely. Of course they do. This gives me an excuse to talk about Titan rockets because I like Titan rockets. Is that bad? So check this out. This is a cross-section of a Titan II missile silo. So you have three big components. You have your blast lock, you have your bird cage over here, and then you have the silo. There's a diverter down there. See the diverter? So the interesting thing about a Titan launch pad is that the diverter, you have a split diverter, and then the flame trenches actually go 180 degrees from the bottom, right? You have a diverter, and they go 180 degrees, and they go up and they go out. So if you ever seen footage of a Titan missile launching, right? The top opens, right? And then, you see the missile start to come out the silo and flames are shooting out the sides. They shoot out the sides of the silo. It's actually pretty cool. There is a deluge system down there. It's not a lot. The reason why it's not a lot is only there to basically protect the vehicle. Because launching out of a silo has its own vibration issues, right? You're launching out of a silo. So there is a deluge system in there. But yeah, it's not as hardcore as like what you'd see on like a regular launch pad. The big reason why, dude, is because, this is designed to be used once. It's designed to be used once, and that's about it. The only water systems you have here are there to protect the vehicle during ignition and leaving the silo. It isn't really about making sure the silo stays intact so you can reuse it. I don't think I need to explain why that's a thing. Yeah, Lex. Okay, you get it. Yeah. If you launch one of those, the pad getting damaged is the least of your concerns. You're most likely about to turn to glass, so Yeah. I was mostly thinking about the sound issues relating to the launch. Yeah, it's just enough to protect the vehicle. That's it. That's all. That's it. Screw the pad. We don't need that. We don't need that. That deluge system's on Spectrum, which is a civilian rocket that's not designed to blow people up. Those are the type of rockets that we like here. That sound suppressor is there to protect the pad. You don't necessarily have to worry about that with an ICBM, dude. It's just there to protect the vehicle. So they have a sound suppressor. They don't the proper nomenclature to say it per like rocket propulsive elements or like how they would classify it, like how you would hear about it in school, would be a sound suppressor. A sound suppressor is usually above the launch deck of whatever you're launching. A pad deluge system is in the flame trench. That doesn't necessarily mean that you can't have sound suppressors in a flame trench. So generally you have a sound suppressor for the vehicle, right? When it launches. You have the pad deluge below it, right? And then in some rocket designs, you have another sound suppressor at the end of the flame trench. Like pad 40 at the Cape and pad 41 have a secondary suppressor at the end of the flame trench. They have a secondary suppressor at the end of the flame trench to make sure the sound doesn't reverb off the ground off the side of the trench and damage the rocket. Yeah. That was actually a good question, dude. Is ISAR a German rocket? Jawohl. Is ISAR's sound suppressor nitrogen or gravity fed? I don't know. I think it's nitrogen. I think they're using a back pressurant. If I had to guess, let me look at the pad. Yeah, back pressurized, T-Man. You know how I can tell? There's no water tower. If it was gravity fed, there'd be a big water tower that's taller than the rocket right there. Finally asked a relevant question. It only took 10 years, yeah. Do we know when the next possible launch opportunity is? I couldn't find anything. So, Animal King, I ain't trying to give you a non-answer here. I'm not trying to give you a non-answer, but they don't know. That's the truth. That if you went to Nico, the engineer that was on the cast, and you asked him when the next time they're going to try is, he would tell you, I have no idea. The reason why is because, well, you got to figure out what went wrong first. Got to figure out what went wrong. And say you're driving down the road in an automobile down the highway and, the vehicle starts doing this, right? Your car starts bumping all over the place. Well, that's not normal. Pull over to the side of the road. But you're not going to be able to tell what's wrong until you get out of the car and go look at it. You're not going to be able to figure out what's wrong from inside from the driver's seat, right? You gotta get out. You gotta see that you blew a tire, right? Right now, ISAR is proverbially, like metaphorically, still in the driver's seat. You gotta figure out what went wrong. First priority after a hold like this is to safe the vehicle. Safe the vehicle. So get the tanks down from flight pressure and start offboarding, egressing propellants, I should say. Get all the fuel out of it. You can't go and look at it until there's no fuel in it. Right? You want to make sure the vehicle's in a safe state for people to get near it. You don't want to send people next to a fully fueled rocket, especially one that's relatively new. Now, older rockets, yeah, sure. A rocket that's tried and tested, yeah, you see Russians walking around a Soyuz like 30 minutes before launch, no problem. They know, because they know it's going to work, because it's been proven, right? Even rockets like SLS, you can walk around that thing when it's fully fueled because it's based off of the shuttle. They know what it's going to do. Right? With this newer rocket, I wouldn't have anybody get near that thing until it's in a safe state. So until it's in a safe state, then you go and look at it. And that's going to take a little bit of time to get the thing detanked. What happened with the rocket? Scrubbed. Auto sequencer caught a hold at T-3 seconds. ISAR is a single-use rocket right now. me. I don't know if they're going to pursue reusability. I'm not sure. Is there an advantage to launch this far north compared to closer to the equator? It's a good question, Gastro. Yeah, yes, there is, but it really depends on where you're trying to go. Now, if there's any KSP players out there, Kerbal taught us that launching from the equator is better, right? Well, yeah, yes and no. Kerbal, it's better to launch near the equator if you're trying to get to what's called low inclination orbits. So, long story short, if you need an if you're trying to launch into an orbit that's near the equator, right, like a geostationary orbit or a geostationary transfer orbit, you'd want to launch at a lower latitude. The reason why is because Earth is a non-uniform sphere. It kind of bulges at the center because we're all floating around on the cool crust of a gigantic molten nickel iron jello mold. That's the right way to say that. So, like, think about if you had, like, a soccer ball, right, and you pushed on it, right? You push down on it, it's going to bulge at the center, not at the top or the bottom, right? Earth does that. The reason why it's an iron nickel core that's molten hot, right? And we're on the cool crust and we just float around on the mantle of hotness. Yeah, scientific. So because of this, at the equator, you have a free velocity gain imparted on your vehicle. Launching from the equator, you're actually, because the Earth is spinning, right? If you go with the spin, you can get a free velocity gain, right? Now, if you're trying to get to equatorial orbits, right, and you're at a higher latitude, you do not get that velocity gain, and you're not working against it, but you need a little bit more fuel to get to a similar orbit. It would be more difficult from a rocket that takes off at 10 degrees north latitude to hit equatorial, right? It would require more fuel than a rocket at 0 degrees north latitude. So a rocket launching due east on the equator actually needs less fuel to get into space because of the Earth's spin, the non-uniform sphere, oblate spheroid spinning of Earth, right? So now I know what people are going to think. So if you're at like 50 degrees north latitude, how are you going to get to an equatorial orbit? Isn't that going to suck? The answer is absolutely yes. Oh yeah, that's going to be awful. Yeah, that's going to be terrible. But is ISAR trying to get rockets to equatorial orbit? No. Nico said at the beginning of the stream that this rocket is trying to launch to a sun-synchronous orbit. SSO is what it's called. Sun-synchronous orbits have an inclination of 97 degrees. So that's a highly inclined retrograde orbit. So a retrograde orbit in context of around celestial bodies. So let's just use Earth as a good example. A retrograde orbit is any orbit that goes against the spin. It goes against the spin of Earth. So I said, if you launched on the equator heading due east, so that would be a flight azimuth of 90 degrees on your compass, right? Like if you're on the compass, like, okay, we're at 0 degrees, we're at 0 degrees north latitude, we're on the equator, launch due east, right? You're going with the spin. And because you're going with the spin, you get a free velocity gain. We talked about that. Now, if you're going retrograde, you're going against the spin. Now, remember what I said about that spin helping you. If you're trying to get to equatorial orbits, you need less fuel, right? But if you're at a higher mid-range latitude, north or south, it's going to actually hinder you because now you need to compensate for that extra velocity gain. You need more fuel to get there, right? In these sun-synchronous retrograde, slightly retrograde orbits, so it's an inclination of 97 degrees, which means if you're at Endoya, which is, I don't know what north latitude Endoya is at. Let's just say, I'm going to guess like 60 or 70. 70 degrees north latitude, right? To get into a retrograde orbit, you're going to have to launch northwest, right? You're not launching due north, right? But because you're so far north, you're not spinning relatively as much as you would be on the outside of the, like down at the equator, right? So if you're trying to get into a polar orbit, it actually requires less delta V than if you were trying to get to a polar orbit from 0 degrees inclined. It's actually harder to reach polar orbits from lower inclinations. And it's easier to hit polar orbits from higher inclination launch sites. Weird, huh? Yeah, Earth is just, it's from Earth not being a uniform sphere. So, why build a launch site this far north? Well, they're trying to get to sun-synchronous orbits. That's the big one. And honestly, you don't need as big of a rocket to get to sun-synchronous. I'm dead serious. If they launched Spectrum, if ISAR had a launch site at 0 degrees north latitude, so if they had a launch site on the equator and Spectrum was trying to hit a sun-synchronous orbit, you would have a severe decrease in payload capacity because you have to account for the Earth spinning during your launch trajectory. You're not spinning relatively as fast at a higher inclination, so it's easier to get to these polar orbits. ISAR was very, very, very smart when they decided to build that launch site there, as considering their demographic, right? What are they trying to do? Well, they're trying to make money launching stuff into sun-synchronous orbits. Okay, now the next question I know that's going to get asked is, where's the money in sun-synchronous orbits? Spy satellites are in sun-synchronous orbits. Does that make that clear? Anytime you're watching like a spy thriller movie and they're like, oh yes, we have another satellite coming into range now. It's in a sun-synchronous orbit. What is a sun-synchronous orbit? How does that work? A sun-synchronous orbit is a type of orbit that you can put a satellite into that has an orbital perturbation that is because of the Earth's precession. So Earth, I said, is that big, gigantic nickel iron jello mold thing. The geographic center of Earth is not where the center of gravity is of Earth because it's a big churning, jiggling jello mold, right? So the center of gravity actually rotates around the center axis of the Earth. That's kind of why the Earth is like spinning all over the place. It kind of spins with this crazy axial tilt, right? Earth's axial tilt is what, like 20, I forget what it is, like 27, 21 degrees or something. So it's like if you spun a top, right, and the top started doing this, that's what Earth is doing. But in space, going 66,000 miles an hour around the sun. Pretty cool, huh? So, spy satellites are in these sun-synchronous orbits to use that precession, use that off-axis wobble that the Earth has to influence the orbit. So the spy satellite, or Earth observation satellite, as everybody likes to call it now, to basically make sure they fly over the same point at the same time every day. Why is that useful? Well, if you're trying to look at what your enemy has at an air base at 8 a.m., or if you're trying to look at what your enemy has at an air base, you would really want some backlighting, right? If you're going to try to image what planes are at an airfield at night, you're not going to see anything now, are you? So spy satellites have to have the sun behind them. If they don't have the sun behind them, you're going to go to take a picture, and it would be like if you tried to take a picture of your friend's car at night with the headlights on from the front. You took the picture, all you'd see is the headlights, right? You wouldn't see the car. You wouldn't see your boy trying to look cool and in the driver's seat, right? So these sun-synchronous orbits are very important to have backlighting. The sun needs to be behind the satellite so it can take a picture, so you can see what the hell the satellite's taking a picture of, just like a camera flash, right? Now, I mean, the other thing is you could put a big flasher on your satellite to, take the flash, but I'm pretty sure people would notice that. Like, nobody wants to, oh, you took my picture. Gonna move my planes now. No, I don't think we'd be able to generate the power in space currently to make a flash light enough to be able to light up the ground so you could see it. That'd be kind of funny, though. But that's what infrared is for, too. But shh, we don't talk about that. 23.5 degrees on the axial tilt. Thank you. So ISAR is trying to target sun-synchronous orbits because that's where spy satellites are, so good defense. And that's where a lot of Earth observation satellites are, too. Nowadays, it's not just spy satellites. If it was the Cold War, yeah, it'd be all spy satellites. But that's not the case all the time now. It is a lot of Earth observation for climate observations, meteorological services, or just something like Google Earth. Google Earth uses a lot of satellite pictures. These SSO companies sell to companies like Google, and they put it on Google Earth and Google Maps and stuff and make a lot of money. So there's a good market for sun synchronous. Yeah, sorry, a little bit of a long-winded explanation, but that's why it's so far north, because they're targeting polar orbits. Polar orbits are easier to get to at higher latitude. No problem, Gastro. Yeah, good stuff, right? Was the GoldenEye satellite in a sun synchronous orbit? No, it doesn't need to be. The GoldenEye satellite doesn't need to be in a sun synchronous orbit. A polar orbit is fine. I would want a polar orbit if I was going to Project Starfish a satellite like that. So, okay, nerd time. The GoldenEye satellite from James Bond, from the 96 James Bond movie, is just a nuclear warhead that's on a satellite up in space. First of all, nobody does that. That's superbly illegal. And I know who's going to enforce that. It's kind of a gentleman's rule between countries that have nukes and rockets to move those nukes far enough. Yeah, we don't do that. Let's call it a gentleman's agreement and leave it at that. If you really want to know the regulatory piece of legislature that governs that, it's the 1967 Outer Space Treaty. Do not put nuclear warheads in space. So GoldenEye is one of those. It's from a fictional James Bond movie. Don't worry about it. What GoldenEye is designed to do is create a pulse. It blows up a nuke in the upper atmosphere. And that's something that was learned during nuclear testing from the Soviet Union and the United States during the Cold War. We did it with a project called Project Starfish, where we blew up a nuke in the upper atmosphere and then couldn't figure out why on the other side of Earth, a bunch of electronics got fried from nuclear radiation. Little Weird, right? Okay, you blew it up on one side of the planet and it fried a bunch of electronics on the other side of the planet. That's great. You probably did something that we don't want to do, right? So what happens is our Earth's magnetic field. Earth's magnetic field carries that nuclear energy around. If you blow up a nuke in the upper atmosphere, you can create an electromagnetic pulse and the magnetic field will pick it up and absorb it. And wherever it comes down, you're going to zap the snot out of that place. And that's what happened in the movie. So, honestly, just a polar orbit, a medium Earth orbit, fluffy for a satellite like GoldenEye, MEO, anything that goes through the magnetic field, yeah, sure. You just wait till it gets into the magnetic field, blow it up, and it'll zap whatever you want. Yeah, true story. Oh, yeah. Yeah, stuff like GoldenEye absolutely exists. Well, not the weapon systems, but the phenomenon is absolutely a thing. Oh yeah, that happens. You can blow up a nuke. If you blow it up on one side of the planet in the upper atmosphere where the ionosphere is, where the magnetic field is, it'll zap everything on the other side of the planet. Oh yeah, oh yeah, that's a thing. Can the GoldenEye satellite fire EMP in the rain? Yeah, probably. Did it happen? Well, it happened from nuclear testing. As far as we know, nobody's made a satellite that does something like that. Because, once again, you'd be in gross violation of the 67 Outer Space Treaty. And it's not like we can't monitor what everybody launches into space. Actually, guys, that's something that's kind of unspoken between all the major space powers, right? Like, China, the US, Russia, they're all telling each other when they're going to launch something. Now, they're not going to say what's on it, but they're all saying what they're going to launch. And everybody, to be 100% honest with you, everybody has not nuclear deterrent satellites, but there are satellites that are capable of detecting extra radioactivity inside of the magnetic field that everyone has. They're I want to say they're SIGINT satellites, signals intelligence, but I don't know what they are. I don't know where they are. I forget. I don't remember. But yeah, like, so if you launch something with nuclear material on it, everybody else is going to know. Like, you're not getting around that. And that is something that is honestly, that's probably a good thing. Like, that's probably for the better. Like, thinking about it, that's probably a good thing. Whose electronics got fried? Well, when we tested Starfish, Ciantic, it was out in the Pacific, so fortunately we only fried part of Hawaii. What? We weren't that dependent on electronics at the time, so it wasn't that big of a deal, but also... Sats can't detect nuclear material on launch. Oh, yeah, you're probably right. Yeah, no, you know everything. You're right. Yeah, sure. Yeah, you know. Yeah, just correct everything that I say. That's fine. Remember Cassini, how some people lost their poop about its RTG? Yeah, but it was declared, right? Like, if you're launching a probe with an RTG... Like, okay, when we launched, like, Mars 2020, when we launched Perseverance, we let everybody know what we were launching. It has nuclear material on it. It's not going anywhere near you. Don't worry about it. Yeah, Project Starfish fried Telstar 1. That's right, Garfagon. Yeah, additional bit of information. It was a rocket that was fired from Andoya in 95 that almost started World War III as the Russians didn't know what rocket it was at first. Yeah, exactly. That's the thing, you know, everybody likes to beat the, it's Russia versus the USA versus China, blah, blah, blah. No, everybody works together, guys. Everybody works together because you do not want to be the person that launches a rocket and doesn't tell them about it and start World War III. Everybody talks to everybody else. Like, I know people probably don't want to hear that, but some of you might, and it is, honestly, when I first learned about that, that's super reassuring, right? Oh yeah, we're launching this right now. Where's it going? What is it doing? Don't know. At least not on accident. Yeah, exactly. Yeah, right. Yeah. Huh. Everybody has strict range rules for a reason. Sometimes your test stand turns into a flight article. Now you realize how big of a problem that actually was, right? Like, undeclared launch. That's not great. That's really not good, man. Starfish Prime. Project Starfish is from Suicide Squad. Yeah. I love how you're all experts on this after Googling it. That's real good. I was getting that off the top of my head. Everybody's an expert now that they Googled it, though. Sorry, I had to. I had to. I love you, buddy. I'm sorry. I had to. All right. That's going to do it for the Spectrum launch coverage. I hope you guys enjoyed it. It was fun. What do we want to do now? It's 5 o'clock. I didn't Google squatted, you know it. Maybe I wasn't talking about you. Sir, you got me. I'm sorry, man. Oh, boy. Hey, look, you guys dish it to me all day. I'm not going to dish it back. I'm not going to not dish it back, all right? Candle King, you're going to bed? Yep. So the big red button is not the same one as making a latte? No. You didn't get me because I looked it up on Safari. Why are you using Safari? Why are... I'm sorry, NASCAR. Like, I don't... Why are you doing that? Why would you do yourself a disservice like that? Nah, it's all good, Ike. I'm just messing, dude. Sorry. I like having a good time. I would expect nothing less from my chat to dish it right back to me, though. You know what I'm saying? There are many gentlemen's agreements in space. For instance, all space safety and tracking providers can detect spy satellites. They just don't post the TLE data and everybody's happy. Yep. There you go. That's it, man. Everybody knows what everybody's launching. That transparency is why you're not nuclear fire right now. Like, Kind of an important footnote, dude. All right. I'd say I want to go back to playing KSP. Can we go back to playing KSP? Let's go play KSP. Let's do that. All right. Give me a quick second here. Actually, we could do space news now. You guys want to do space news? We do space news. Actually, nah, this was enough space news. I want to play Kerbal for the rest of the night. Is that fine? And then maybe do after hours after that. Pissed my bump. Yeah, we'll do space news tomorrow. Like what my original plan was. I was gonna go back to playing KSP. Yeah, YouTube, please. All right. Yeah, we'll get back to KSP testing here. Just give me a quick moment, guys. I'm just gonna go down. I'm gonna go down and grab. Actually, I don't really need to grab a bite to eat. Let's just switch over to Kerbal. I gotta pee. I'll be right back. Let me fire up YouTube and yeah, we'll go from there. And Titan demands pets. That's right. Yes. All right, I was trying in short words to not tell you that I had to go to the bathroom, but you know. Okay.